Hello everyone, welcome to my channel. Today is March 28th of 2021 and my name is Steve Matthews. I can be found on YouTube under Teeth of the Lamb and also on Facebook under just Steve Matthews, Coos Bay, Oregon. I'd like to start this video with just a brief biblical scripture. For of him, and through him, and to him are all things, to whom be glory forever. Amen. Romans 11:36. The title of this video is The Dark Side of the Moon. Is it self-illuminating? When we talk about the dark side, we're talking about during a crescent moon, either waxing or waning. And we're talking about the shadowed side of the moon and how you can see the whole silhouette of the moon. And when we see this is just before sunrise or just after sunset, when the crescent moon is still in the sky. During the waning crescent, as the moon approaches the sun, and the crescent becomes smaller, the dark side becomes brighter. And during the waxing crescent, as the crescent enlarges, the dark side will become gradually dimmer. This whole process raises some very intriguing and interesting questions that we're going to explore today. Forgive me if you hear noises in the background. A good microphone is a good thing unless you have a house full of kids. And I think a lot of you can relate to that. I've asked them to be quiet, but that's not working too well. We'll proceed. There is one more segment from the pages of Job that I'd like to read real quick before we get into the meat of this video. I think it's appropriate for what we're going to discuss today. Job is answering God with the following words: He which shaketh the earth out of her place, and the pillars thereof tremble, which commandeth the sun, and it rises not, and sealeth up the stars, which alone spreadeth out the heavens, and treadeth upon the waves of the sea, which maketh Arcturus, Orion, and Pleiades, and the chambers of the south, which doth great things past finding out, yea, and wonders without number. And that leads us into the first wonder. Why would anyone think the moon's producing its own light? That's a great question. And let's see why somebody could think that. Well, it's because when you look at the shadowed side of the moon during a crescent, you can see many of the same features that you see during a full moon. They claim that this is due to the reflection of the sun off of the face of the earth, and that it travels 239,000 miles to the moon and back to our eyes in such intensity it looks like direct sunlight. Did you know that the new moon vanishes for 3 days and 3 nights between the waning and waxing crescent? Well, it's an interesting thing because for those 3 days and 3 nights, one would expect that you should be able to see a new moon with full onslaught Earthshine, but we don't. The comeback for that or explanation is, well, it's too close to the sun and the sun is too bright, lighting up our atmosphere so we can't see it. Not so fast. The moon is sufficiently high enough in the atmosphere, the day after the last sliver of the crescent vanishes and the day prior to its reappearance, the moon is still sufficiently high enough that you should be able to see it the following day. After the last sliver of crescent vanishes, at this point, the day after, we should see a new moon with full Earthshine, and the day before the emergence of the crescent, we should also see a moon with full Earthshine, but we don't. I'll call it a full Earthshine moon. So the moon is sufficiently high enough above the horizon the day after the crescent vanishes and the day prior to its reappearance. And it should be visible with full Earthshine, but it's not. I've had conversations with some very successful and talented astrophotographers that at one point must have thought the same thing I do, that it should be visible, a new moon with full Earthshine, because they said they've tried and the atmosphere is too bright. Well, they left it at that. That's assuming that the moon follows the course that the heliocentrists believe it does. But what if it doesn't? What if something else is occurring? Because we should be able to visually see it during that time. Now, moving away from the visibility of the dark side of a crescent moon being visible, just for a moment, onto a full moon being visible near the horizon at the same time that the sun is still up. That's a problem also, which has no good scientific explanation. So they claim, well, we're seeing an image of the moon that's transferred through refraction around the curvature of the Earth, and that's how we see the moon when it's full and the sun is in the sky at the same time. I don't buy that. And I'll tell you why. It's because in that explanation of refraction, now you have a bigger problem. You have two moons. You have the refracted moon and the physical moon. So at what time do those two merge? You're going to at some point have the refracted moon vanish away, and then you're going to have up over the horizon comes the physical moon. Now, how do you deal with that? Now, I know they will, but it doesn't make sense. You've got two moons. You've got a refracted moon, which is an image, and transparent, because it's possible that you could see through a refracted moon. So there you have it. Some people could say that the moon is transparent. You see, the problem that they're presented with is this great curvature that you can't see around. And a full moon occurs opposite of the sun, which is on the backside of the Earth, the dark side. Now let's move away from the sun and the moon visible at the same time and go back to our crescent moon and its visible dark side. When you look at the crescent moon and its shadowed side and you take pictures of it, you'll see real quickly that the same features are visible there as are on a fully lit, bright, full moon. And this is said to be nothing more than reflection of sunlight from the Earth that lights this, but it's extremely intense for a shaded side of the moon. And you can see that real well when we overlay a full moon with the dark side of the shadowed side of a crescent moon. Watch, we've enhanced this a little bit to make it stand out better. But the same craters that are visible on the fully lit full moon are visible on the dark side of a crescent moon. I mean, these things are intense during a full moon and during a crescent moon. Look at those craters. I mean, you can see them clearly. And yes, we've enhanced it some so you can see what's shining and what's not. This is not what you would expect from reflection at a distance of 239,000 miles away. Unless the Earth is much brighter than what they say. To look at that, it's almost exactly like a fully lit full moon. I find that odd. You can make out all of these craters and more on the dark side of a crescent moon. So this is the moon as you would see it during a crescent, but when you set your camera correctly, you can see the whole silhouette. And it's intensely bright, and this is probably why some would say that the moon is self-illuminating. Look at that. These are some that I took, and you can see the stars. Now, NASA's, you never see stars. Look how bright those are. The same as a full moon. Now, personally, I don't think that what you're seeing is reflection from the Earth. And, they could easily prove that it's reflection from the Earth if they had cameras and stuff in so-called outer space. But they never show you that. And they could easily disprove it. But they don't. And that just yells deception to me. Now, I'm just presenting you with some things that I think and that I see, and I'll let you make your own choice of what you want to think or believe. But I do have my own beliefs. When you look at the shadowed side of a crescent moon, it looks like this full moon. And that's extremely odd. But you do see craters when you get near the terminator line. The video footage that's playing right now was taken by a man named Mel Gig, and he's a very, very successful astrophotographer, I would say, taking some fantastic images of the moon, but he's a master with his camera. And here he adjusts his settings and moves the highlighted area off to the side to get a better shot. But look at that, looks like a full moon. And tell me that's just reflection from light off of the Earth. I think he's done a good job on this. But this is actual footage, and I give credit to Mel, and I'll have a link to his video down in the comments, and to some of the other images and stuff that I've pinched off the net. I'll have links to some of their pages too. I don't have them all, but a good portion of them. And some of these are my own images. But look at those highlights on the same places that are brilliantly bright on a full moon, or bright on the shadowed side of a crescent. Isn't that just amazing? Then you start seeing craters when you start getting right on the terminator line where the light meets the dark. Then you can make out craters And it doesn't take long after that they start really vanishing. But you don't see any craters on the dark side. That's just like a full moon. So what's going on? I don't know. He's going to adjust his settings here, so let's look at this. When it stops, I paused it, and you can really see the highlights. Does that look like reflection off the Earth to you? And this is raw footage. I don't believe he did any enhancement to it. Mel's a bright man. He's of course confronts me on every issue, but that's okay. That doesn't make anybody a bad person. Look at those. Well, I think all this stuff is so fascinating, and I think there's a lot of things that we just don't know. And I think we've been misled a lot too, deliberately. Now here I'm overlaying that full moon with his shadowed side of a crescent moon. They don't match up perfectly, but I had to rotate it some to get it to match up. But when you look at this full moon and you go back to the dark side of the crescent moon, they look remarkably identical. And you just I wouldn't expect that if it were from reflected light. Nothing that intense. That takes intense light. It's as if something has just filtered, put a neutral density or an ND filter over that section of the moon. Remember, the reason given why you can't see a new moon between the waning and waxing crescent is because it's too bright. So really consider this. This is a total solar eclipse. I would say that's pretty bright. And it has Earthshine. Total solar eclipse, Earthshine. The new moon should be visible if seeing Earthshine during a total solar eclipse is possible. Well then, seeing Earthshine during the 3 days of a new moon absolutely would be possible. We have filters. Remember, the claim is that the sun is too bright. That's why you can't see a new moon for 3 days. The new moon completely vanishes for 3 days and nights, and nobody can see it. Now they show you this during the total eclipse. I question this image. And just a reminder, did you know the moon vanishes for 3 days and 3 nights? And they claim that you can't see it because the sun is too bright for these 3 days. You tell me, is it too bright? Or is that just an excuse? You certainly should see it at the horizon because there's plenty of time the day after and the day before the crescent. Now we're going to move on again, but later we're going to talk about the distance to the moon and if reflection off the Earth is possible. It's also called Earthshine. But now to the Discover image that we've all seen from 1 million miles out in deep space past the Earth. Now look at this. How bright do you think that Earth would have to be to light that moon on a crescent moon? It would have to be intense. This would be a photographer's nightmare with two intensely bright objects overlapping. And it'd be as bright as that crescent. The moon, they show no reflection off of. It's very, very suspicious. And I say it's a photographer's nightmare. And if we can get this, then we can get the new moon, shots of the new moon with Earthshine while the sun is out. I mean, don't we have satellites? Don't we have deep space orbiting telescopes? There's a lot of questions. But this is interesting, where you have a fella using a simulated celestial sphere where they use a flat plane as their ground and a celestial dome with all the stars pulled in close. But this is interesting because on a flat plane you could definitely see the full moon and the sun in the sky at the same time with no difficulty. Yes, that huge curvature that presents a problem, and why they have to use a refracted image of the moon following the curvature of the Earth. Well, let's listen quickly to what he has to say, and then I'll show you some images that I took of the full moon and sun at the same time.
I've written a little simulation here using Visual Python. This represents the sun, the yellow dot. The white dot here represents the moon. Here's the flat Earth. This is our apparent experience of the Earth and the apparent spherical dome of the sky overhead. Notice I can grab this and change the perspective. And let's just stop it here for now. Okay, it's not quite opposite, but notice that when the sun is setting in the northwest, because it's way to the north along this the ecliptic, which is the path of the sun. That's the name of this yellow path, by the way. It's called the ecliptic. But it's north of west. Here's west, and this is setting in the northwest. The moon is essentially opposite the sun.
See on this phase chart, if I were where the red arrow is going clockwise, you could not see that moon in the back. There'd be too much curvature, and that's their problem. Now let's look at some of the images that I took real quick of a full moon and the sun in the sky at the same time. This is a theodolite shot of, shows you the position of an item in the sky, and that's the moon over there, hard to see. Here's a close-up of it, faintly visible through the haze as it's coming up over the horizon. That's a full moon. And so here it is a little bit later when I could see it, barely see it. Here's a picture of the same thing, the same moon, full moon, and here's the location of the sun at that time. So they're both in the sky at the same time. Here's both times comparison. This is another shot of the same moon, but in black and white. But remember, on a flat surface, you don't have any problem seeing them both at the same time. It's only when you introduce that huge spherical curve. Now I'm going to play one more explanation of the sun and moon visible in the sky at the same time and some of its difficulties.
How can a full moon be visible in daytime, simultaneously at sunrise and sunset, at opposite sides of the Earth? The problem is that a full moon should not be visible in daytime, as the moon is over the horizon. To someone on the ground, the horizon looks flat. But it doesn't explain a full moon after sunrise or before sunset. In reality, sometimes a full moon can be seen for up to half an hour longer than the night. In daytime, the full moon is always low on the horizon. The sun can be easily seen at sunrise because it's a lot bigger than the Earth. On the other hand, refraction of the light from the moon can explain how a full moon can be visible in daytime.
Interjection here. A refracted moon could be transparent because a refracted moon has no substance. So again, when does a refracted moon merge with the physical moon? If it were refracted, we would see two moons. As the refracted moon fades, we would then see the physical moon rising above the horizon. There clearly is a problem.
There's a problem. The sun should be a lot easier to see at the horizon compared to the moon, given that the sun is supposed to be a lot farther away from the Earth. But the reverse is true. It's odd that the moon can be seen after sunrise and before sunset. This may be because moonlight and sunlight have different properties and behave differently. Also, it is possible to see a blood moon at sunrise or sunset. In summary, the problem is that light from the sun travels in a straight line and is not bent or refracted by any forces. But this is inconsistent with the refraction of the moonlight and light bending to follow the Earth's curvature. This is a paradox. There's no explanation in physics for this.
Now let's get a perspective of just how far away the moon is. They claim that the moon is 239,000 miles orbiting the Earth. That's a long ways. Can you imagine that Earth reflecting sunlight onto that moon with the intensity that we saw, where it looks as if somebody just put a filter over a full moon? All the craters are lit up? I don't think so. That's a long ways away. I took this out at one of our beaches here in Oregon. That represents 239,000 miles. I have a 12-inch globe and a 3-inch moon, and they're spaced about 30 globes apart, which is about 239,000 miles. Now this is a neutral density filter or simulation of it. What you would see, you see the crescent, and when you lessen the intensity of that filter, you see exactly what we see in the images of that moon, of a crescent moon. You see all of the same features you see in a full moon. And here's a comparison for you. The right hand is an actual picture that's been enhanced, and then I've taken a picture of a full moon and just put a neutral density filter over it and darkening it and lightening it. Makes a pretty good simulation, doesn't it? And some think that there could be dark spheres, and I forget what they call them, but that cause some of these phases and stuff. And I think we just don't really know. But it does raise some interesting questions. Look at that. It looks almost exactly like what we see on a crescent moon. But that's my simulation. But now we're going to pop back to that solar eclipse and the moon that showed Earthshine right over the sun. I did a little bit of enhancing of this because I question the validity of this image. It's a really high quality image. But by changing the levels and stuff, you can see different things. But look at that. Look at the Earthshine on that. So that's what they call it anyway. Is it really Earthshine? I don't know. I doubt it. But look at the edges of this. When you really zoom in, all around the edge of it, you see pixelation. Now I know every image, when you go deep enough with zoom, you'll see pixels. But this is only around the edges of this entire moon. I think it may have been photoshopped, or something maybe even better than Photoshop. But I don't think it's real. You don't see this pixelation anywhere else on this image, just around the edge of that moon. It's like they superimposed it in there. So I'll show you this and I'll let you decide. But I don't see that pixelation anywhere but around the edge of that Earthshine and moon, right over the eclipsed sun. So what do you think? So that was just zooming in. This is changing some of the levels. And if you'll notice, the moon and the outer glow of the sun appear to be two different images. You can color correct one without affecting the other at times here. And if you look at the pixelation around the edge, it's the same thing. It's like they superimposed that moon into this solar eclipse. It's interesting. I can't tell you. I'm not experienced enough to tell you if this is a fraud or real. But I suspect that it's not real. And they want you to believe that that moon is always there. Maybe it's not. Maybe it really does vanish like suggested in Enoch. And when it goes through its portals on its circuit. I can't tell you, but look how I can color correct both of these images separately. As if they're two separate images independent of one another. Anyway, that's interesting. Here's just a normal solar eclipse, and here's their perhaps fraud. Now, this is interesting, because if you had a Earth bright enough to light the moon 239,000 miles away, it would look more like this. And their moon would look, on the back side, would look more like this. It would be super bright, at least as bright of intensity as what we see on a full moon. I know the naysayers will say, no, that couldn't be. But yet, you can't have it both ways. Either that Earth is bright enough to light that solar eclipse moon, that you can see it even over the sun, or it's not. And it's bright enough to light up the crescent, the shadowed side of the crescent moon. This just reeks of deception, and there's a lots more problems with it than what I've said. This is an actual image of the crescent moon and its dark side. Doesn't that look like a full moon? Now there are other problems, such as there are no stars in this image, and when we take pictures of the crescent moon and it's bright, we have to adjust our cameras to where stars show up. And clouds, they have no parallax. It's clearly a composite. Look at all the squares jiggling around here. Multi composite image. There is absolutely zero parallax on the clouds when you watch the time lapse. Parallax between the clouds and the ground. No, it reeks of deception. And I get that same thing from people that really don't even question this stuff. They say that's not real. Kind of like the car in space. Just defies all reason. So here's my little simulation of some of the parallax that I think you might, just a simulation of, you would see upper and lower clouds and stuff that would shift, and in 4 or 5 hours, you know how the clouds form and dissipate and move about in just a short time. They don't show any of that. So, deception. By imagery. They say that Discover 1 million mile image was taken on July 16th, 2015. And it's a snapshot off of the web, some of what they say about it. Take it for what it's worth. So let's go back to the crescent moon and how brightly it's lit. The sun can do this. But the sun can't light this. So what's up with that? Why do I say this isn't real? Let's look again at the distance to the moon. So I put this out on the beach, my globe, and that moon way back there is supposed to be what's lit up by the reflection off of this Earth. Now, when you're close to the moon and you move backwards, it reduces in size. Pardon me. It'll keep reducing down in size as you go further and further back until it reaches a small size where it's just large enough to account for the 30 globes between the moon, 30 feet. And then it stops there. It doesn't reduce anymore. So compare this to their million-mile Discover image of the moon passing over the face of the Earth. Yep, 239,000 miles at minimum is a tremendous distance. Now the sun reflecting off of that globe and lighting that moon, especially when half of it or part of it is lit up by the sun, it just does not seem feasible to me. You decide. Now the Discover supposed image of a million-mile shot of the Earth with the moon passing over its face has size issues with the moon. As you can see, that bottom photo, 3 of their moons it takes to cover that Earth. And on mine, just a little over 4. And they say that the moon will fit across the diameter of the Earth 4 times. So when I simulate this 1 million miles, I have a 12-inch globe and a 3-inch moon and place them 30 feet apart. I come up with a completely different size moon, much smaller than what they show. So when I take photographs from what would be 1 million miles and then a distance of what would be 2 million miles based on the appropriate numbers, I get different sizes from what they get. And I use a ruler to measure the size of the globe, and then rulers to measure the distance of 4 moons. And their moon's too big. When I move my moon real close to the Earth, it fits across the face of the Earth 4 times. And the globe is 6 inches. And I carry this out next on 1 million miles, and then what would be equivalent to 2 million miles. So that's side by side. So we move on to the 1 million miles distance, and again we make the globe 6 inches across, and we see what the 239,000 miles or 30 feet, what it's done to the moons. Well, they've increased in size, which is only allowing for that 30 extra feet. Then you go to 2 million miles, and again we have the 6-inch globe. So my dog's shaking. And you can see the moons are about the same distance apart. But we go to NASA's image, which is supposed to be just 1 million miles, and we make sure that the globe is, again, 6 inches, so everything's in proportion. 6 inches, or close enough. That's their 1 million mile discover image. Then we measure the distance on their moons. Remember, this only accounts for the 239,000 miles between the Earth and the Moon. And we get 8 3/4. Let's look at my 1 million mile moon. I've got 30 feet between my globe and my moon. It's a 12-inch globe and a 3-inch moon. 6.5. Where are they getting that extra distance on their moons? You see, there's clearly a problem here. Either their satellite, which I don't believe, was much closer. Now this, I must have made some kind of an error, because it actually shrunk a little bit. I didn't go any further than that because I didn't think I needed to. I don't think it would decrease in size the further I get away, but maybe that's is the way it works. I'll have to go back and try that again. But that's my 2 million miles. It's 6 1/4, so we've lost about a 1/4 of an inch there. We'll check it one more time to be sure. They've got about 8 3/4. This is what NASA's image would look like if you had 4 moons that would cover the face of the Earth, and 239 miles between. And here is NASA's measurements compared to the 1 million and the 2 million mile simulation that I did. There's some discrepancies for sure. And here is the size difference of their moon compared to mine. My moon fits equally 4 times across the diameter of the Earth. Well, I think that just about concludes it for today. I hope I've given you some things to consider, or some things to laugh at. Either way, it's all good. You come to your own conclusions of what you think. And if you have any suggestions or some comments or ideas, feel free to leave them in the comments below. I'm always open to hearing other people's opinions. And until next time, like and subscribe. Have a great day, and always keep on smiling. That makes life good.